Hello, my name is Michael. I'm actually with Texas Instruments, and this demonstration is about an 82 microamp per megahertz microcontroller with embedded FeRAM that we have built for MHz harvesting applications. So we actually believe that flash is not the ideal memory that we can use for microcontroller. That's why we have looked at the FeRAM. So what's special about the FeRAM? FeRAM is a non-volatile memory similar to flash. However, it is really random access, so it's actually in this case addressable similar to an SRAM, not like a flash where you have page erase and page write. Also the speed is kind of different. For the FRAM, in this case we can really access it with read and write with 8 megahertz. It's not like with flash where you have a long erase and then a really long write that you actually have to do. Also the power is kind of different. FeRAM is really native, working from 1.5 volts. It's not requiring 10 or 12 like on a flash where you have a charge pump. And then finally, actually, the endurance is quite different. On the flash, you're usually limited to 10K samples. In our case, we actually have over 100 trillion write and erase cycles on that one. So let me actually get here to the demo. What we have done is you will find there's 2 experimenters boards. On one device, we actually have a small flash microcontroller. On this device here, we have a small microcontroller with FeRAM embedded. And we have a few test modes that I would like to show you to actually just give you an idea, especially on the right, how impressive that looks like. So the first mode is something where we actually try to write as fast as possible into the device. On the flash, as you can see, we roughly have about 13 kilobytes per second that we can write into the flash device. And this is with about 2.3 milliamps of current consumption. On the FeRAM device, we're getting 1.4 megabytes per second, and that means we are actually 100 times faster. However, the current consumption in that same time is only about 730 microamps, what is about a third of the flash device. We have now another mode where we actually do like an apples-to-apples comparison, and we're now writing with 12 kilobytes into both devices at the same time. On the flash, there's no difference. This is exactly what we have seen before, 2.3 milliamps. However, on the FeRAM device, we have currently only about 10 microamps, and this is really because it mainly sits in low power mode, waits for the next byte to come in, writes it back, and goes back into low power mode. So this is really the nice comparison where the writes are really superior to the flash device. And that's why we believe it's really good for energy harvesting applications. If you think about like a solar, sun goes up, sun goes down. What do you do if the sun goes down? There's no power left. And so in this case, every kind of write that you do to the memory is already non-volatile. It means from software point of view, the next morning when the sun comes up, the software is all the same like before. It means you do not require any kind of battery to retain your state. Thanks for your attention.